Try to see it my way. Do I have to keep on talking till I can go on? While you see it your way, run the risk of knowing that our love may soon be gone. We can work it out. We can work it out. Think of what you're saying. You can get it wrong and still you think.
Section 2.3 is on polygons, and so I guess we better start by talking about what a polygon is. And a polygon is a closed geometric figure. I suppose I could add to that by saying with only straight sides, or only straight edges. You can also call them edges. So for example, if we're going to draw some, these are all straight and it's closed, right? This would not be an example because it's not closed, and this would also not be an example even though it's closed. It doesn't have a straight edge there, not a straight side, so that's also not a polygon. So, you know, it can be very simple, like this triangle. It can be a little more complicated. They can be very complicated. As long as I'm drawing all straight sides, doesn't matter what I do, as long as I close it up and I have all straight sides. So these are all examples of polygons. You certainly don't need to copy the ones I did. And then the way we name these things, as I said, this is an example of a side. So this polygon has 4 sides, and the points here and here and here, all these are called, each one's called a vertex, or if you're talking about a whole bunch of them, they're called vertices. Okay, there's 2 main types of polygons, convex polygons and concave polygons. You've probably heard these terms before in science class, right, to do with lenses. I always think for concave, I think of going in the cave. So a concave lens bends inward and a convex lens bends outwards. So if we're drawing convex polygons, it would be things like our triangle again, or square, or trapezoid. These are all examples of convex polygons. It's the type you normally see. A concave polygon could be something like this, right? And it's this action here, which is the concave part. So how do you tell if something's convex or concave? Here's what you do. You look at the vertices. So let's start with the square. If you look at the vertices, and if I was to join the vertices, not the ones side by side, I've already joined those, but if I was to join them, I'd join that to that, and I'd join that to that, and now they're all joined. And those lines that join the vertices are inside the polygon. Same with this one. If I was going to join these ones, I would join this to that, I'd join this to that, and they're inside. This one, there's none to do because it's all just the edges. But this one, if I was to draw them, some would be inside, like that one, but there would be others that are outside. And this right here is the reason that this is a concave polygon. So, just to make things easier this year, we're only going to deal with convex polygons. We're not going to deal with concave. Alright, one more term to define a regular polygon. A regular polygon is when all sides and all angles are equal. They're all the same. So a regular triangle, for example, what's another name for a regular triangle? It's called an equilateral triangle. What's another name for a regular rectangle? Another name for a regular rectangle is a square. Alright, now we're going to learn some formulas. So one formula we're interested in is, how do we figure out the interior angle sum of an n-sided polygon? Boy, that sounds confusing. So what I'm basically saying is, if you have a polygon with a certain number of sides, which we're calling n, what do all the interior angles add up to? Okay, now a word about interior and exterior angles. So interior angles are angles like this angle, and this angle, and this angle. The angles you're used to, those are interior angles. So I'll just start with that, and we'll talk about exterior angles in a second. But what I want to know is, what do those all add up to? So let's go with our basics. The most basic polygon has how many sides? 3. You can't have less than 3 sides in a polygon. So we have a triangle, next one would have 4 sides, a rectangle or a square, then we'd have 5 sides, which is going to be hard for me to draw. 1, 2, 3, 4, 5, good, and then we'd have 6 sides. And let's just stop there and see what we've got. So when we have 3, 4, 5, 6, what's the sum in a triangle? We should already know that. In a triangle, the angles always add up to 180 degrees. In a square or a rectangle, what do they add up to? Well, think of this as a square. How much is each one of these angles here? 90, 90, 90, 90. Add those up, you get 360. But there's another way to think of that. If I was to cut this into two triangles, right? Triangle there. How much is in this triangle? 180. How much in this triangle? 180. So 360 because it's the same as 2 times 180. I'll put equals 2 times 180. How about this one? You might not know how much a pentagon has, but we can use the triangle trick. Let's go from here to here and also here to here. Do you see that I've broken it into 3 triangles? 1, 2, 3. So I have 3 times 180, which is 540 degrees. And one more. If I do my triangles, I could make 1, 2, 3, 4. 1, 2, 3, 4 triangles. So I'd have 4 times 180, which is 720 degrees. Hopefully you're seeing the pattern here. By the way, we could call the top one here 1 times 180. So when there's 3 sides, it's 1 times 180. When it's 4 sided, it's 2 times 180. 5, 3 times 180. 6, 4 times 180. What's the relationship between this number and this number? This number and this number. This number and this. This number over here is always 2 less than that. So if I wanted to know how many sides there are, angles there are for a polygon with n sides, then what I would do is take the n, subtract 2, and multiply it by 180. Hope that makes sense. The sum of the interior angles is equal to n minus 2 times 180. I suppose I could write 180 degrees here, and I could put a dot here to show I'm multiplying if that's confusing to you. Right? So if n was 6, I would do 6 minus 2, which is 4, and then 4 times 180. Yep, that's exactly what I did. Okay, so let's do an example of that. How many sides does a regular polygon have if its interior angles add up to 1,440? So I know the sum. The sum is 1,440. So in this case, I'm going to plug the 1,440 on this side of the formula. So 1,440 equals n minus 2 times 180. How to solve this? Well, one way you could do is you could do mountains over here on the left, but the other way you could do it, since all of this is being multiplied by 180, I could divide by 180 here and divide by 180 here. I like doing that. I think it's a bit faster. 1,440 divided by 180 is equal to 8, so I'm left with 8 equals n minus 2, and then just add 2 to both sides. 10 equals n, or n equals 10. So the regular polygon that has interior angles adding up to 1,440 has 10 sides. It's called a decagon, if you want to know the name of it. So there's your answer. Okay, now we're going to figure out the degree of each interior angle, not the sum, but the degree of each of them in a regular polygon. So again, let's draw some of these basic ones. We got our triangle, we've got our square, our rectangle. Actually, if it's a regular one, then I guess it's a square. And we have our pentagon. I'll do the best I can. Okay, so again, we probably already know some of these. Well, let's write down first of all what we know about the total angles. We know that the total in this one's 180. We just did that on the other side of the page. We know total this one's 360. We just did that. We know this one's 540. So if we want to know the degree of each one of the angles, well, how many angles are there in here? 1, 2, 3. And it's a regular polygon, which means they're all the same. So what are you going to do? You're going to go 180 divided by 3, and you get 60. And you should know that, right? In an equilateral triangle, it's 60, 60, 60. Okay, how many angles here? 4. So 360 divided by 4 equals 90. And we should know that too. In our square, it's 90, 90, 90, 90. Might not know this one, but we can figure this out the same way. How many angles? 1, 2, 3, 4, 5. So we're going to go 540 divided by 5, and if you do that, you get 108 degrees. Okay, so how are we doing this? Well, basically what we're doing is we're getting this number the same way that we did before. So in other words, we're just going to use the same formula we did before, but now we're dividing it by how many angles there are. Well, how many angles there are is just the n part. So what we're going to have is exactly the same formula as we had before, right? That top part, this n minus 2 times 180, that's exactly what we had before. But now we're going to divide it by n to see how much each of the angles, how much its value is. So again, if you want, you can put times here, you can put 180 degrees. Yeah, So for example, if I wanted to know the interior angles in this regular pentagon, I would do 5 take away 2, which is 3, times 180. That gives me 540. So now I know total in this pentagon there's 540 degrees, and then I divide by n, which is 5, to get how much each angle is in the pentagon. Okay, so find the measure of each interior angle of a 16-sided regular polygon. So we're just going to plug it in. The angle is equal to, the angles I guess are equal to, n is 16, so 16 minus 2. We're going to multiply that times 180 and divide by n, which is 16. So I get 16 minus 2 is 14 times 180 divided by 16. And if you throw that into your calculator and do the math, you're going to get 157.5 degrees. Each of the 16 angles, interior angles, in a regular sided polygon has a degree measure of 157.5 degrees. Alright, now we're talking about exterior angles, so I need to tell you what an exterior angle is. Let's draw our triangle again. And if we want to know what the exterior angles are, what we do is we extend one of the two sides that at a vertex. At every vertex, extend one of the two sides. So you could extend it like this, or if you wanted to, you could extend it like this. Either one of those ways you want. I'll keep it like that, and I'll extend this one like that, and I'll extend this one like that. And then the exterior angle is this angle here, and that angle there, and that angle there. So how much are those angles? Well, let's imagine that this is a regular triangle, an equilateral triangle. If so, we know the angles are 60, 60, and 60. So how much are these green angles here? Well, that makes a straight line, so it has to be 60 plus some amount to get, how much is the angles in a straight line? 180. 60 plus what equals 180? 120. So this would be 120 here. Same up here. 60 plus what equals 180? 120. And same here. 60 plus what equals 180? 120. So if we were to add those together, the 120 plus the 120 plus the 120, we would get a total of 360 degrees. Let's quickly do one more. We'll do a square or a rectangle. So I'm going to extend this one, and I'll extend this one, I'll extend this one, and I'll extend this one. And the angles we're interested in are that one, and that one, and that one, and that one. And since this is 90, how much is this one? Another 90. And this one's 90, so this one's also 90, and this one's 90, so this is 90, and this one's 90, so this one's 90. They're all 90. So if I add up all those exterior angles, 90 plus 90 plus 90 plus 90, guess what I get? 360. In fact, it turns out for whatever one you draw, for which however many sides a polygon has, if you add up all the exterior angles, it's always going to equal 360. Hey, that's nice and easy. Last one, what's the degree of each exterior angle of an n-sided regular polygon? So if we go back up here, if I knew that I was dealing with a triangle, for example, so I'll draw our triangle, and I wanted to know how much each of the exterior angles was. I know I just figured it out up here, the 120, the 120, 120, but see if we can figure out a formula for it. Well, here's my exterior angles. Here, here, and here. And I know that the total of those is equal to how much? The total of these three red angles is 360. It's always 360. How many exterior angles are there? 3. So if I want to know how many there are, I'd go, or how much each one is, I'd go 360 divided by 3. So they're each 120 degrees. Is that what we've said? Yep, right here. How about a square? Well, with a square, we know again that all the exterior angles here, 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 they all add to 360 again, but this time you're dividing by 4, because there's 4 exterior angles. So it'd be 90 degrees. So in other words, what you're doing every time is just taking 360 and dividing by n, just dividing by how many sides there are. So the formula is going to be 360 divided by n. What's the measure of each exterior angle in a regular nonagon? A nonagon has 9 sides. So nice and easy. Whoa, that says 9 sides. Nice and easy. You're just throwing it in here. Each angle, or the angles I guess, are equal to 360 divided by 9, 40 degrees. Each of the exterior angles in a regular nonagon is 40 degrees. And the last one, what type of regular polygon has an interior angle 3 times the exterior angle? Okay, well, we've got exterior and we've got interior, and we don't know either. So why don't we call one of them x? Which one would be easier to call x? I think exterior would be easier, because interior is 3 times as much. 3 times that is 3x. Now, if you look at the interior and exterior angles of any of these, what do the interior plus an exterior always equal? What does this red angle here plus this one equal? Well, it's a straight line. It equals 180. This plus this, straight line, 180. This plus this, straight line, 180. So these two things together, the x plus the 3x, has to equal 180. So we'll just solve this. X plus 3x is 4x. Divide both sides by 4. And you get that x equals 45 degrees. So the exterior angles are equal to 45 degrees. The interior are 3 times as much, so that's 135 degrees. Which of those will be really useful? I would say the exterior angles, because look, we can throw it into this equation right here to figure out what n is. So that's what we'll do. If each exterior angle is 45 degrees, and we know that the exterior angle is equal to 360 divided by n, the number of sides, I just need to solve this in order to get my answer. Why don't I put this over 1 and cross multiply? So I'll multiply that times that and that times that. And if I do that, I get 360 equals 45n. Divide both sides by 45. And if you do that, you get n equals 8. It is an octagon, a regular octagon is what the shape is. A regular octagon has interior angles 3 times the exterior angle. Okay, that's it. The questions do get quite a bit more difficult in the book, but you've got the basics here to get you started.
I have always thought that it's a crime, so I will ask you once again. Try to see it my